Welcome to the deep dive. If you've been following the AI world, you know the pace, especially with open weight models, is just, well, it's incredible.
It really is. Almost hard to keep track some weeks. Feels like a gold rush for new ideas, new architectures.
Totally. And that's why we're here today. We want to cut through some of that noise and really dig into two major new releases shaping accessible AI.
Right, we're looking at OpenAI's new GPT-oss models, the 120b and the 20b.
Their first open weight ones since GPT-2, which is huge news in itself.
Definitely. And then comparing them with Google's latest, Gemma 3N, which is all about mobile-first innovation.
Exactly. So our mission is to unpack these, look at the architectures, the performance, how they were trained, and, what they're really for.
It's fascinating because they represent such different philosophies, different engineering choices to get to, well, impressive results in their own ways.
Right. From managing massive parameter counts efficiently to squeezing power onto a phone. What's jumped out at you initially just looking at the headlines?
For me, it's that contrast. OpenAI is really pushing for this powerful general reasoning capability, but making it runnable, relatively cheaply.
Ah,
While Google's Gemma 3N is just laser focused on that on-device experience, making AI truly portable and, crucially, multimodal, two very distinct paths.
that's a perfect way to frame it. Okay, so let's start with OpenAI's GPT-Os, released August 5th, 2025. Big deal, as you said, return to open weight, and they're under the Apache 2.0 license. Why is that specific license such a big deal for folks listening, especially researchers?
Well, Apache 2.0 is incredibly permissive. It essentially means these models aren't just viewable, they're usable for research for commercial products with very few strings attached.
So it really lowers the barrier to entry.
Massively. It aligns with what OpenAI seems to be promising here. Strong performance, low cost, efficient deployment, even down to consumer hardware potentially.
Hmm.
It lets people build real things without hefty licensing hurdles.
Okay, so performance and efficiency. They're transformer-based, we know that, but the key seems to be this mixture of experts, or MOE architecture. Can you break down what MOE actually does for the model?
Sure. So think of MOE not as one giant brain doing everything, but more like a committee of specialists.
Okay.
When a piece of information comes in a token, the model doesn't use all its parameters. Instead, it routes that token to only a few expert networks, the ones best suited for that specific bit of data.
Ah, so it's activating only a small part of the whole model for each step.
Exactly. This means you can have a model with a huge total number of parameters representing vast knowledge, but the actual computation needed for inference for getting an answer is much lower.
Gotcha. And the numbers are pretty stark, right?
They are. The GP-oss-120b has 117 billion total parameters. Sounds enormous,
Yeah.
but it only activates around 5.1 billion per token. The smaller 20b model has 21 billion total, but activates just 3.6 billion. Both use 4 experts per token.
That's a huge difference. It's like having a massive library, but only needing to consult a few key books for each query. What else is in their architectural toolkit?
They're using some proven techniques too. Things like alternating dense and sparse attention patterns, similar to GPT-3, which helps capture both broad context and local details efficiently.
Okay.
And for inference speed, they use grouped multi-query attention GQA. This lets different parts of the model share some calculations, cutting down on memory use during inference.
Right. Less data movement, faster results.
Precisely. And they use rotary positional embedding, ROPE, for understanding word order. The big thing ROPE enables here is very long context windows, up to 128,000 tokens.
128K, that's massive. You could feed it a whole book.
Pretty much. Crucial for complex reasoning that needs a lot of background information.
So let's talk training and what these models can do. OpenAI seems focused on reasoning and using tools. What went into that?
Well, the training data set was immense, trillions of text tokens. And there was a heavy emphasis on STEM subjects, coding, and general knowledge.
Makes sense for reasoning.
Definitely. And the training itself was a huge undertaking. The 120B model alone took 2.1 million hours on NVIDIA H100 GPUs.
Wow.
After that initial training, they used advanced reinforcement learning, similar to their O3 model, specifically to boost reasoning and tool use. That includes enabling sophisticated chain of thought, or COT.
Right, COT lets the model kind of show its work, breaking down problems, helps a lot with accuracy on tricky stuff.
Exactly. And they also introduced something called the Harmony Chat format.
That sounded interesting. What's the idea there?
It's designed for more complex agentic tasks. It defines different roles, system, developer, user, but also adds channels. Think of it like having a separate channel for the model's internal scratch pad versus the final answer it gives the user.
Ah, so you can structure more complex workflows, maybe where the model thinks step by step internally.
Precisely. It allows for that layered thinking in action. Plus, they added variable effort reasoning training, meaning developers can actually choose a reasoning level, low, medium, or high. You can trade off latency for better performance, depending on what your app needs. Need a quick answer? Go low. Need deep analysis? Crank it up to high.
That's a really practical feature for deployment. And the tool use is built in too, like web browsing and code execution.
Yep. They could use a browser tool to look things up online and a Python tool to run code in a Jupyter environment. So they're not just text in, text out. They can actively interact with information and computation.
Okay, performance-wise, how do they stack up?
Pretty impressively for open models. The 120B is apparently near parity with OpenAI's own of 4 Mini on key reasoning benchmarks.
Wow, okay.
And the 20B is comparable to O3 Mini. They're showing strong results in areas like competition math, expert Q&A, coding benchmarks like Code Forces, even things like health conversations,
Right.
often beating existing proprietary models in those areas.
That is impressive, especially tying back to the efficiency goals. Now, the elephant in the room with open models, safety, what did OpenAI do?
They put a lot of emphasis on it. Comprehensive safety training, filtering out harmful data like CBRN material during pre-training.
CBRN being chemical, biological, radiological, nuclear.
Correct. But here's a really interesting part for the research community. They did what they call malicious fine-tuning, or MFT experiments.
Trying to deliberately break it, essentially.
Kind of. Trying to understand the worst-case misuse potential. They fine-tuned it with malicious intent to see how dangerous it could become.
And the result.
They reported that even these deliberately misused versions didn't reach what they classify as preparedness high-risk levels.
Which means, what's preparedness high?
That's OpenAI's highest internal risk category. It signifies severe potential harm, enabling novel bioweapons, large-scale autonomous cyber attacks, that kind of catastrophic risk. So not hitting that level, even when pushed, is a significant data point.
Definitely. And one other safety note, their chain of thought isn't supervised for alignment. What does that mean?
It means they didn't specifically train the internal reasoning steps, the COBIT, to be safe or aligned in a particular way.
Why not? Wouldn't you want the internal thoughts to be safe too?
It's a deliberate choice for research transparency. By not steering the internal cookie during fine-tuning, they allow researchers to study the model's raw reasoning process more directly.
Ah, I see. So the community can develop and test their own methods for monitoring or guiding that internal reasoning rather than inheriting OpenAI's specific implementation.
Exactly. It makes it a better testbed for research into interpretability and new alignment techniques.
Okay, that's a really thorough look at GPT-oss. Let's switch gears now to Google's Gemma 3M, previewed back in May 2025. Very different focus. Mobile first, on-device AI.
Right. This is all about putting capable AI right onto your phone, your tablet, your laptop, building on their Gemini Nano work.
Yeah.
And again, open weights, responsible commercial use license, same theme of accessibility, but aimed squarely at the edge.
So if GPT-oss uses MOE to make big models runnable, how does Gemma 3N achieve efficiency on tiny, power-sipping mobile hardware? What's their architectural magic?
Their big innovation, developed with mobile hardware partners, is called per-layer embeddings, or PLE.
Per layer embeddings. Okay, how does that work?
It's clever. Instead of keeping all the model's parameters, specifically the large embedding tables, in the device's main RAM all the time.
Which is usually very limited on mobile.
Exactly. PLE stores those embeddings in fast local storage like the phone's flash memory and only caches the necessary bits into RAM as needed.
So it's like offloading part of the model's memory footprint.
Precisely. The result is pretty dramatic. They have 5 and 8 billion parameter versions, but because of PLE, they run with an effective memory footprint closer to 2 or 4 billion parameter models. We're talking just 2 GB or 3 GB of dynamic RAM needed.
That is a huge reduction. Makes running powerful models on a phone actually feasible.
It's a game changer for on-device. And that's not all. They also use a Matryoshka transformer architecture matformer.
Like the nesting dolls.
Exactly like the nesting dolls. The architecture literally contains smaller, fully functional submodels nested within the larger one.
What's the benefit of that?
Flexibility. Developers can dynamically choose how much compute to use on the fly. Need speed or saving battery. Use a smaller nested model. Need max quality. Use the full outer model. all from the same model file. You can even pick intermediate sizes.
That's brilliant for adapting to different device states or user needs without juggling multiple model files. Any other efficiency tricks?
Yeah, they also use things like KVC sharing key and value projections in the attention mechanism to save memory bandwidth.
Okay.
Advanced activation quantization using lower precision numbers to save memory and speed things up. And conditional parameter loading.
Meaning it only loads parts it needs.
Right. Like if you're only doing text tasks, maybe it doesn't need to load the parameters for understanding images or audio right away, saves initial load time and memory, and can pull them in later if required. And for images, it uses a MobileNet V5 vision encoder designed for efficiency.
Okay, and you mentioned images, and audio multimodality is a big differentiator here, right? Especially for mobile.
Absolutely. Gemma 3N is explicitly designed for multimodal input. Audio, text, images. And they say it has significantly enhanced video understanding, too.
So you could talk to it, show it something, type something, all in one go.
That's the idea. Fast, low-footprint experiences. They claim it's about 1.5 times faster on mobile than the previous Gemma 3 4B model, with better quality. It enables high-quality on-device speech recognition, translation, and handling those interleaved inputs across modalities.
That really opens up possibilities for how apps interact with the world. How about languages?
They've improved multilingual support, highlighting particular strength in Japanese, German, Korean, Spanish, and French, based on benchmarks like WMT24++.
Yeah.
And it has a 32K token context window, which is pretty decent for on-device analysis.
So putting it all together, what's the real impact of Gemma 3N? What does it mean to have this kind of AI in your pocket?
Well, first, privacy and offline capability. Since it runs locally, your data doesn't necessarily have to leave your device.
That's huge for many users.
Definitely. And it enables apps that work without an internet connection. Think real-time interactive experiences reacting to what your phone's camera sees or microphone hears, advanced transcription, live translation, all happening right there on the device.
And it's accessible for developers.
Yeah, through Google AI Studio for trying it out in the cloud, Google AI Edge for actual on-device integration, plus Kaggle and Hugging Face. They're making it easy to experiment.
Okay, we've really dug into both GPT-oss and Gemma 3N. Let's zoom out now and think about the bigger picture, these divergent paths they represent.
Yeah, it's clear they both want efficiency and accessibility, but how they get there is fundamentally different.
Right. OpenAI's GPT-oss uses mixture of experts to make a massive model computationally lighter for each token, aiming for powerful general reasoning that can run on decent hardware down to consumer GPUs.
It's about making big intelligence more accessible for broad tasks, whereas Google's Gemma 3N uses per-layer embeddings and Matformer to radically shrink the effective size and make powerful AI fit onto resource-starved mobile devices.
So hyper-efficiency and deep integration for that always-on on-device experience.
Exactly, and their core strengths reflect this. Gemma 3N has that native multimodality, audio, vision, text, all processed directly. It understands the world in a more integrated way, right on the device.
While GPT-oss is text-focused at its core, but achieves its real-world power through very sophisticated tool use, browsing the web, running code, it extends its reach by interacting with external capabilities.
Right, it's reasoning about the world and using tools to interact, versus Gemma 3N directly perceiving multimodal input.
Which leads to those distinct target environments we talked about. Gemma 3N, mobile-first, on-device champion. GPT-oss is scalable reasoning powerhouse from edge devices up to powerful workstations for complex agentic tasks.
But there's common ground, too, beyond just being open weight.
Like the commitment to open, commercially usable licenses.
Yes, that shared goal of democratizing access is huge for the whole ecosystem, especially the research community. And both are emphasizing safety, even if their specific testing methods, like OpenAI's detailed MFT reports, differ in transparency and approach.
So for researchers and developers listening, we're seeing two really compelling but different ways to build capable and efficient open-weight AI.
Absolutely. One path is making massive models sparser and more runnable for general reasoning. The other is re-architecting from the ground up for lean, integrated, multimodal intelligence on the devices we use every day. Both incredibly innovative.
We have definitely unpacked a lot today. OpenAI's GPT-oss models with their MoE architecture, strong reasoning, really interesting tool use, and then Google's Gemma 3N bringing truly powerful multimodal AI to mobile through things like PLE and Matformer. It just shows how dynamic this open weight space is.
It's an amazing time. The pace is just relentless. Lots of new tools and possibilities opening up.
So here's something to think about as we wrap up. As this on-device AI like Gemma 3N gets more capable, and these powerful open reasoning models like GPT-OS become even more accessible, how will you choose? Will you prioritize that deeply integrated multimodal efficiency for apps that live on the device? Or the powerful general purpose reasoning with tool use that GPT-OS offers, perhaps needing a bit more hardware?
Yeah, will those paths converge? Will we see reasoning models get leaner or on-device models gain deeper reasoning?
Or will they stay specialized, each unlocking totally different kinds of AI applications we haven't even imagined yet? That's the big question as this landscape keeps evolving. Definitely something to mull over.